Hi everyone. I'm taking advantage and recording. My daughter's napping right now. But this is going to be the review for a mini benchmark that you have on Wednesday. I decided that instead of a larger test, I'm just going to chunk it out into a couple benchmarks. So this is the first part, or I guess the first benchmark for this topic, benchmark 8. Benchmark 8 is, and I'm going to make some notes on here so you know what topics to expect. It's on adding polynomials, subtracting polynomials, multiplying polynomials, and naming polynomials, which was the first thing that we learned. So it's on doing all of that with polynomials. Okay, so I made this little review sheet for you guys to practice. Some of these might look a little bit familiar, but it's good to try them again, check your answers, things like that. Okay, so on this review worksheet, I'm going to work on the left-hand side. So I'm going to do all the odd problems. The even problems will be what you have for homework. Okay, and we're kind of practicing all of this together. All right. Your benchmark 8 I made for you already. It's not too long. I believe it has 8 questions, about 18 questions. There's multiple choice, select all that apply, the drag and drop, and then free response. And it's essentially on everything that I'm going to mention in this video. Okay. It's on Edulastic. You'll have until Sunday at 11:55 to get that turned in. Okay, make sure you guys ask questions during office hours if you have any. Okay, let's get started. So for the first part, I just want you to name the polynomials. Remember that when you're naming polynomials, they need to be in general form. So for example, number 1 is not in general form. I'm going to rewrite it so that the highest exponent, which is 2, is written first. So I'm going to write that term first. It's going to be 6x squared. The next term is the 2x. It's positive, so I'm going to put plus 2x. Okay. Now, remember when you name polynomials, you use the degree, the highest degree, which is a 2, and you also want to use the number of terms that you have, which we have 2. Okay. Because it's a degree 2, we call that a quadratic. And then there's 2 terms, so that's a binomial. Okay, and you're done with that one. Perfect. So number 3, since I'm doing the odds, is also not in standard form. I'm going to rewrite it. So this one, I want to write the negative 5x first because it has a power of 1. The 10 doesn't have a variable. That's a constant. Constants go at the end. Okay. So for the first one, I'm going to write that first. Okay. Take the negative with you because that's part of the negative 5. So it's going to be negative 5x. And then I'm going to put plus 10 because the 10 is positive. All right, so that's in standard form. Again, look for your highest degree. Technically, my degree is 1 if there's nothing written in. So that's going to be a degree 1, which is a linear. And then there are 2 terms again, so that's going to be a binomial. So for this, you want to make sure you study the homework that I assigned at the beginning of last week with naming polynomials. All right. Perfect. So part B, you're simplifying by either adding or subtracting. For number 1, you're adding. When you're adding polynomials and they're in parentheses, you remember to drop your parentheses, which you can. So it's going to be 5x minus 8 plus 7x plus 10, and then combine like terms. Okay, so I have an x here, an x here, and then I have constants that could be combined. Okay, my x's are going to give me 12x. My constants are going to give me positive 2. Okay, so this is going to be my answer. I do want to talk about closure with polynomials. Whenever you add 2 polynomials together, they're going to give you another polynomial. Okay, and remember the definition of a polynomial is it's an expression where your exponents are not negatives and they're not fractions. Well, technically they could be a fraction. Like if you have 1, it's technically 1 over 1. But you can't have fractions like 2 over 3 or like 1/2. Okay, you have to have integers as exponents. That will also give you a polynomial. So we call that as being closed. Okay, so polynomials are closed under addition. Number 3, is the same thing. You're adding, so you could drop everything. Remember, if this was a negative, you would distribute that negative to your parentheses to both terms, but it's not, it's positive. So we're just going to drop everything down. We have negative x squared plus 5x minus 12 plus 2x squared minus 6. Look for your like terms. I saw that a lot of you on your homework were highlighting, and I thought that was really cool. So if it helps you to highlight, go ahead and highlight. It definitely helped me out when I was first learning how to do this. And then just combine. So my greens I put first. So negative x squared plus 2x squared is going to give me x squared. The blue, which is my next term, cannot be combined with anything. So I'm just going to rewrite it. Okay, plus 5x. And then the red, negative 12 minus 6 is going to give me negative 18. And this is my answer. Okay. Perfect. The next one, I want you to multiply each expression. And by the way, on your test, I'm not asking you to use any particular method. You could use the box method, FOIL, or distribution. I'm just going to use distribution for these. I find it a lot easier to do. Okay, so I have one term that gets multiplied to the 2 inside. So I have 2x times x. Remember to add your exponents when multiplying. It's going to be 2x squared. And then 2x times 6 is going to give me 12x. Okay, I can't combine anything, so that's my answer. Number 3, we have x minus 4 squared. Okay, now I'm going to rewrite this as x minus 4 times x minus 4. And the reason for that is squared means multiplied by itself. Like, for example, if you have 8 squared, that's just the same thing as 8 times 8. Well, x minus 4 squared is the same thing as x minus 4 times x minus 4. So that's what I'm doing, okay? So what I'm going to do from here is distribute. Okay, I'm going to multiply the x with x. X times x is x squared. And then I'm going to multiply it with the negative 4. X times negative 4 is negative 4x. Then do the same thing with your next term. Remember to take the negative with you. Negative 4 times x is negative 4x. Negative 4 times negative 4 is negative 6, or I'm sorry, positive 16, because they're both negative. Then you can combine your like terms. I have 2 like terms in the middle. Okay, bring everything else down. X squared, that's going to give me negative 8x since I'm adding 2 negatives, plus 16. And then this is your final answer for that one. All right, number 5. We have x plus 3 times x squared minus 1. All right, so take your x, multiply it with both. First one, x times x squared is x cubed. X times negative 1 is negative x. All right, next term is 3. 3 times x squared is 3x squared. 3 times negative 1 is negative 3. And then combine like terms. By looking at this, I can't combine anything. This one's cubed, this one's squared, this one's linear, and then this is a constant. So what I'm going to do instead is just rewrite it in standard form. On your test on Edulastic, you're expected to write your answer in standard form. You should always write your answer in standard form. If it's not, it's incorrect. Okay, so my answer here is x cubed plus 3x squared minus x minus 3. Remember to take your signs in front with you. All right, and then last one that we're doing is this one here. Again, I'm going to use the distributive property. I just find it's the most practical for doing these. I don't want to sit and draw a box every time, but you're more than welcome to if you want to. 3x times x squared is 3x cubed. This is a linear. This is quadratic. When you add a 2 and a 1, you get a cubic, so x cubed. And then 3x times 5x is 15x squared. Okay, that gives you 2 x's. And then 3x times negative 1 is negative 3x. It's already in standard form. The powers are in descending order. Okay, so this is your review. I also want to note that when you're multiplying, you're also closed. As far as your polynomials go, you're closed under multiplication. Whenever you multiply any 2 polynomials, which is exactly what we've been doing, you get a new polynomial. Okay, so like for example, number 7, here I have a linear. Okay, this one's linear. And then this one is quadratic. And when I multiply those, I get a cubic. Okay, so I think that's kind of neat. There's only one operation that doesn't hold closure for polynomials, and it's division. We'll talk about that later when you end up dividing polynomials. You'll actually do that in Math 3. But yeah, that's the only operation that's not closed for polynomials. You'll end up getting fractions as exponents, and you can't have that for polynomials. We want integers only, positive integers. But yeah, that's it. That's your review. Make sure you ask me questions during office hours or send me an email if you have anything.